Hi, I'm Dr. Steve Warner, and today I'm going to be talking about counting problems. Although counting sounds like it should be an easy concept, students tend to find math problems that involve counting very difficult. Let's start with a really basic strategy for counting problems, writing a list. Sometimes the easiest way to count the number of possibilities is simply list them all. When we do this, make sure that you list things in a set pattern so you avoid accidentally duplicating things in your list or leaving something out. Let's look at a simple example. A menu lists 2 meals and 3 drinks. How many different meal-drink combinations are possible from this menu? Okay, so let's do this by listing first. So let's make our 2 meals, say, chicken and fish, which we'll abbreviate with C and F. And for the 3 drinks, how about water, soda, and juice? Okay, so we could have, for example, chicken and water. We can have fish and water. We can have chicken and soda, fish and soda. And we could have chicken and juice or fish and juice. Notice that there are 6 possibilities altogether. Many of you already might have seen an easier way to do this using the counting principle. The counting principle says that if one event is followed by a second independent event, the number of possibilities is multiplied. So let's look at this example again. The menu that has 2 meals and 3 drinks. Well, event 1 is picking a meal. There are 2 ways to do that. Event 2 is picking a drink. There are 3 ways to do that. The counting principle says multiply the number of possibilities to get 2 times 3, which is 6. More generally, we could have more events. So if event E1 has M1 possibilities, E2 has M2 possibilities, and so on through En, having Mn possibilities, then if all these events are independent, then event E1 followed by event E2 and so on through event En has M1 times M2 times Mn and so on possibilities. In other words, we just multiply all these numbers together. So let's look at an example where we need this more generalized counting principle. A menu lists 2 appetizers, 5 meals, 4 drinks, and 3 desserts. A dinner consists of one of each of these 4 items. How many different dinners are possible from this menu? So the answer is simply 2 times 5 times 4 times 3, which comes out to 120. Another example. How many integers between 9 and 300 have the tens digit equal to 2, 3, or 4, and the units digit, or ones digit, equal to 5 or 6? Well, there are 2 possibilities for the units digit. There are 3 possibilities for the tens digit. And now for the hundredths digit, it could be 0, 1, or 2. So there are also 3 possibilities for the hundredths digit. By the counting principle, we multiply these numbers to get 18 possibilities in total. Factorials. The factorial of a positive integer n, written n factorial, is the product of all positive integers less than or equal to n. So in other words, n factorial is 1 times 2 times 3, up through n. 0 factorial, by definition, is 1. This way, n factorial is defined for all non-negative integers n. So 0 factorial is 1. Just as another simple example, 4 factorial is 1 times 2 times 3 times 4, which is 24. A permutation is just an arrangement of elements from a set. Now I'm going to give you the permutation formula, but keep in mind that you don't actually have to know this formula for standardized tests, since you could use your calculator to compute permutations. That said, for completeness, I'm going to give the formula. The number of permutations of n things taken r at a time is npr, equal to m factorial over m minus r factorial. So as an example, let's count the number of permutations of 1, 2, 3 taken 2 at a time, and then we'll list them after. Okay, the number of permutations of 1, 2, 3 taken 2 at a time, well, we're arranging 3 things, and we're only arranging 2 of them. So it's 3p2, which is 3 factorial over 3 minus 2, which is 1 factorial. So that's just 1 times 2 times 3 over 1, or 6. Let's actually list these permutations. 1, 2, 2, 1, 1, 3, 3, 1, 2, 3, and 3, 2. Those are the 6 permutations of the numbers 1, 2, and 3. Let me show you how to do this same example on your calculator. So we want to compute the permutation 3p2. So first we type in 3, then we go to the math menu, scroll over to PRB for probability, and select NPR, and then we hit 2. So your display will look like this, 3 NPR2, press enter, and the output will give you the answer, which is 6. Let's try another example. 4 different books are to be stacked in a pile. In how many different orders can the books be placed on the stack? Well, we have 4 books, and stacking is just another way of arranging. So we're arranging all 4 of them. So we need to compute 4p4. You could do that directly in your calculator, or you could compute 4 factorial in your calculator, or by hand it's 1 times 2 times 3 times 4, which is 24. One more permutation example. 3 light bulbs are placed into 3 different lamps. How many different arrangements are possible for 3 light bulbs of different colors? 1 red, 1 green, and 1 yellow. Well, we're arranging 3 light bulbs into 3 different lamps. So we're arranging all 3 of them. The answer is 3p3, or 3 factorial, or 1 times 2 times 3, which is 6. Combinations. A combination is just a subset containing a specific number of the elements of a particular set. Again, I'm going to be giving you the combination formula, but on a test you could just use your calculator. For completeness, I'll include the formula as well. The number of combinations of n things taken r at a time is NCR equals n factorial over r factorial times n minus r factorial. Notice that the formula is almost the same as the permutation formula. There's just an extra factor of r factorial in the denominator. Let's count the number of combinations of 1, 2, 3 taken 2 at a time, then list these combinations. Okay, so what we want is 3c2. This is equal to 3 factorial over 2 factorial times 3 minus 2, which is 1 factorial. So that's 1 times 2 times 3 over 1 times 2 times 1. Cancel, cancel, and we get 3. So what are these combinations? 1, 2, 1, 3, and 2, 3. Those are the 3 combinations from the set 1, 2, 3. Notice that 2, 1 is a different permutation from 1, 2, but it's the same combination, so we do not list it again. Let's go over how to compute this in our calculator. Very similar to what we did for permutations. We're going to compute 3c2. So we type 3, we go to the math menu, scroll over to probability, PRB, and we select NCR. We press 2, so the display will look like this. 3 NCR2, press enter, and we get an output of 3, which is the answer. So what's the difference between a permutation and a combination? Well, a permutation is just an arrangement. You use the permutation formula whenever you want to order things, stack things, rearrange things, or choose specific tasks for people. A combination is a grouping. You use the combination formula when you want to split a group of objects into 2 piles or form a committee of people. Let's look at an example. How many committees of 4 people can be formed from a group of 9? Well, this is just a combination. It's the combination 9C4, which comes out to 126. Either use the combination formula or the method I showed you using your calculator. You probably want to use your calculator. Let's look at another example. A chemist is testing 5 different liquids. For each test, the chemist chooses 3 of the liquids and mixes them together. What is the least number of tests that must be done so that every possible combination of liquids is tested? Well, this is the combination 5C3. We're taking 3 of the 5 liquids and mixing them together. And we want to know how many ways we can do that. Again, just use your calculator and you'll get an answer of 10. One more example. A wall is to be painted one color with a stripe of a different color running through the middle. If 7 different colors are available, how many color combinations are possible? Be careful in this problem. Even though the word combination is in the problem, this is not a combination. It's a permutation. The reason is because when you paint your wall one color and the stripe a different color, if you interchange the 2 colors, that's a different coloring, meaning we're actually doing an arrangement here, not a grouping. So the answer is 7P2. We're taking 2 colors from the 7 and arranging them. One for the wall, one for the stripe. So 7P2, you can either use the formula or put this right in your calculator to get an answer of 42.